This is Austin. I wanted to get in a little bit about that was a weird way to start. Get into network programming. And the program I'm going to be writing today is actually it's not really my code. It's from the book Hands-on Network Programming with C. But so the code, I mean, it's mainly from that. There's like little differences that I changed because I noticed some things that weren't 100% accurate, and I changed them to make it a little, more accurate. Or I'll get into that when I start writing the code. But this is going to be in different parts. So this is the first part of the series. So right now I'm going to be working on the server. Then after that I'm going to be working on the client. So let's make a directory called So if you don't know what a TCP socket is, so there's in networking there's TCP protocol and the UDP protocol. They're both, if I can remember correctly, they're both data packets. But so TCP has error checking. So when something gets sent across the network, it checks to see if all the data got sent, where UDP just keeps sending data without checking for any errors. Yes. I'll link a video that could explain that more, but if you search up TCP and UDP on YouTube, I'm sure you'll get a good explanation of it. So I'm going to call this server.c, right? All right. All right, to get started, I'm going to do this. I don't know if it's 100% needed. I just know that for my compiler, if it doesn't see this, then some things, it'll show errors. Well, as far as my linter goes, it'll show errors that I don't like. It's not going to hurt if you define that anyways. All right, so netdb will obviously include our network stuff. stdio, the input and output like printf, strings, string manipulation, memcopy, stuff like that. UniSCD for file handling like close and read, and then error no for handling errors that netdb spits out. I'm going to have some command line arguments here. So it's going to require 2 arguments. The getADR info function takes 4 parameters, right? For the first parameter, you're going to specify like the host. They call it the node. And then the second parameter is going to be like the service, right? Which you could also, say the port and service, kind of same thing. Third parameter would be the info struct, ADR info struct, which we just defined right here. And then the last parameter is going to be another ADR info struct. Well, the third parameter was an ADR info struct, but it was a pointer. And the last parameter, the fourth one, is going to be a double pointer ADR info struct that will get filled. So I'm zeroing out the hints struct, just so we don't have uninitialized data. Uninitialized data is bad because you don't know what could be in there if it's uninitialized. All right, after that, do hints.ai family. So AI family, you can basically tell whether you want to do IPv4 or IPv6 addresses. We're going to do IPv4. And then sock type is if it's TCP or UDP, or there's probably others, but we're just going to stick with TCP, which is sock stream, which it looks like I spelled wrong. 0. We're going to set it to 0. We're just going to say that we're setting no flags. The last parameter of ADR info
returns the list.
But because we should only have one address, right? Address struct, because we only have one server. We're just gonna do this, right? So we have our pointer to our bind address, right? And then we just make it a double pointer by putting this and in front of it. And we're not going to search through the list because it's not going to be a list. It's only going to be one element. So if it's greater than 0, it means an error occurred, and then the error will put into error no. And those there's different error numbers that you can check. Like if you look at turn, yeah, these are the different errors that can be returned. So you can check those if you want, but it might not be 100% necessary right now anyways. Then we're going to make our socket. Yep, so socket returns an int. It's just a file descriptor to the socket. Everything in Linux is a file, even WebSockets, and we can read and write to it like we do any other file, which we'll see in a second here. And it returns a negative number if there's an error. As we created our WebSocket, a WebSocket's important for establishing a connection with other clients. It creates an endpoint for communication and returns a file descriptor to the endpoint. But when you create a socket, it's always going to be the lowest number file descriptor. That'll definitely be important later when we start creating more in our code. And then what bind does is it associates a socket with a local address. So we're kind of like saying, oh, hey, you made this socket, but we're going to make this socket associated with whatever address we put in, get ADR info here, which is whatever we specify for the command line argument. So this argument 1 would be like the host name, like local address. And argument 2 would be like the port, like 800 or 8000 or something like that. And it returns 0 if it was successful. If it was unsuccessful. Now we're not going to need that struct anymore. Then we'll be listening for any new coming connections. And 10 basically says, right, that's the most amount of people we can have in our queue at once, right? I'll actually read it. Listen marks the socket referred to by socket listen as a passive socket. So it'll be used to accept incoming connection request using accept. And then for what we did was we set 10 as the backlog, which is the max length for the queue of pending connections, that the max it can grow. And then, yeah, it returns 0 on success. Because we're doing this repetitiveness for our errors, right? We can make a function for this. After we listen, let's make our FD set. All right, so an FD set is something we're going to use for select right? Let me describe for the function select. And basically what select does is it monitors multiple file descriptors, finding, it'll wait until one of the file descriptors become ready for some class of input-output operations, right? For us, we're going to check to see if the file descriptors are ready for reading. And it'll check the FD set to see if all of the file descriptors in the FD set are ready. And we these macros right here will basically put things into the FD set. So we have this FD set master, right? First we zero it out, make sure that there's nothing inside of that set. Then we put something into the FD set. We put this file descriptor into that FD set, file descriptor set. And then we set max socket equal to listen, socket listen, which I'll get into why we did that a little bit later here. Yeah, so it's synchronous input-output multiplexing, right? So basically what that means is that it's synchronous because it has to wait for file descriptors to be ready for a set of IO operations. If it did not wait, right, for those descriptors to be ready and it just handled other stuff while it was waiting, then it would be asynchronous, right? Which it's kind of a downfall, but you can get ways around it that shouldn't be that bad in our case anyways. You really shouldn't notice it much of a difference unless you're having like a ton of people connect, which we're not. And then multiplexing, right? Let me get into multiplexing. Yeah, so multiplexing basically is a method by which multiple analog or digital signals are combined into one signal over a shared medium, right? So in this case, it's all these FD sets are being put into select and handled over select, right? So that's what multiplexing means. Select will wait until one of the file descriptors becomes ready. So one of the file descriptors in the FD set. So this struct will be in the last parameter for select. It'll wait a max amount of this many seconds and microseconds before it stops. And then it'll just return something if it's waited that long, which is useful because you don't want it to, if there is no timeout struct, it'll wait indefinitely. And I don't like waiting indefinitely for things. So I'm putting a timeout of 4 seconds. So all these structs, this is readfs, right? The parameters that arguments it can take in these parameters. You can do readfs, writefsd, and then acceptfsd. FDS, I mean, not FSD, FDS. So readfds will check all the file descriptor sets that are ready for reading. These ones are ready for writing, which I've kind of already said. And this is accepts, which we won't get into, so I won't talk about. We're just going to make it 0 or null, however you want to do it. And this right here should be so out of all three of these sets, right, these FD sets, should be the maxed, the number, the highest number out of these three plus 1. So because it needs to be that because it needs to check through all of the file descriptors in all of those sets. So now we're going to make our program loop here. I'm looping through all of the file descriptors, right? Or, yeah. It's the file descriptors for the sockets. And I start at 3. Why do I start at 3? Why don't I start at like 0? Well, there's a simple answer for that. And this program is going to be ran in the terminal, right? There's already 3 file descriptors that are taken up by the terminal. That's std in, std out, and std error. std in is file descriptor 0, std out is file descriptor 1, and std error is file descriptor 2. So those are already taken up. So it'd be pointless to start the loop at 0 because it's not, those are already going to be taken. So that's why I start at 3. And then what we're going to do here is you see that the max socket is set to socket listen. Eventually it'll change, right? And as we add more sockets, the max socket will become the next socket that's created, because every time a socket's created, it's the lowest number file descriptor that can be possible, but it's always going to be a higher number than the previous socket that we did. And we set our reads, so it'll check to see if these are ready for reading. And I didn't say this actually. So once it checks to see if these file descriptors are reading, it will write into that FD set which ones were ready. And we can check it with FD set or FD is set to see if we can go through all the file descriptors and see which ones are set. It macro clears all descriptors from the set, FD set adds the file descriptor to the set, then FD is set, the test if the file descriptor is present in the set. We already know that we're looping through all of our sockets. Then we check which ones are ready for reading right here, see if it's inside of this read set that we set. And then right here, we check to see if I is equal to socket listen, right? Because we know, okay, we already know that when we create the socket up here, it's the lowest number way up here. Where's it at? We create this socket up here, we already know it's going to be 3. Because, I mean, this is assuming you're starting like no other application at the same time, which most people don't really do. This is how it is in the book anyways. So this is going to be 3 because we know STD, we already went through, STD in is 0, STD out is 1, and SD error is 2. So so socket listen is the only other file descriptor at this point that we're making, so it must be 3. So we say, okay, well, and this is going to be the same case for when we make our client. It's going to be the only file descriptor at that point when it's sending out a message to get connected. I can't think of the word for that right now. When it's saying that it wants to connect at that point in the program, in the client program, it'll also be the file descriptor will also be 3 because it'll be the only file descriptor in the program as well. And then what we do is we accept that connection. The accept needs so the accept system call is used with connection-based socket type. So sock stream, which is TCP, and sock seek packet. And then TCP kind of sends sequence numbers, so I don't know if that's related, but it's it's not what we're talking about right now anyways. So it accepts the first connection request on the queue of pending connections. We have the queue of pending connections from select, right? For the listening socket. And then what it does is it creates, sockfd creates a new connection socket. So this is the new connection socket, right? This is one that's being returned. And then the newly created socket is not in the listening state. And then this socket is unaffected when we call this. There's something I didn't mention about select as well. And select is reentrant. So reentrant basically means, here if I can get a good definition of this right here, multiple invocations can safely run concurrently on multiple processors or on a single processor system where a reentrant procedure can interrupt in the middle of its execution and then safely be called again. So yeah, reentrancy is really important especially for networking and things like this, because there's going to be so many different, obviously, sockets being created at the same time. We need some call like address info, get address info, to not interrupt those other connections that are going on with our computers. So this is going to be a pointer to, obviously we know that it's a pointer to an ADR info structure. The structure is filled with the address of the peer socket, and the format is determined. The format of address returned to ADR is determined by the socket address family. And then, so we need to specify a length. That's why we have a client length here. And it's supposed to be, it needs to have the size of the structure that you put in, for the size of client address, the size of the structure of socket ADR. The return address is truncated if the buffer provided is too small, right? So if for whatever reason the buffer you did, if this isn't big enough, then it'll be truncated. And then this value will be longer. So this will be bigger than the size of the structure. Well, I mean, it'll be a bigger size than the size of the structure if the structure isn't big enough. Yeah. So we get the connected socket, and then we say, okay, well, if the socket, the client socket, right, which I think right now is literally just if it's greater than the max socket, right, which this client socket's a socket we just created. If it's greater than max socket, which is right now just socket listen, for the first iteration, then the max socket is now socket client, because it's going to be a bigger. There's not really a reason why at the first iteration it shouldn't be bigger. So that should be the max socket. Just so when we read select, it's actually going through every socket. Clean that up a little bit. And then get name info, right? It is used to convert the socket address to a corresponding host and print the address to the terminal output. Then NI numeric host is to make sure we have a numeric form of the host name. So we're just getting, the address name. And that's all we're doing here, is just getting the numeric form of the address with this address buffer. And it's getting filled in right here. We need to provide a link to it. Length of the address buffer here, and then we just print off the address that we got. Something interesting I noticed is that we're using, it's supposed to be socket ADR, but we're using ADR info. I wonder if I should be able to change this. It's strange that was working. I think right here. I think it's part of this. Yeah, right here. It's actually part of the ADR info struct is the sock ADR. So, but I'm going to change that to that. So, yeah, I didn't notice that until now. I'm assuming this should work like this, though. Interesting that it would have worked. Well, I guess it makes sense. Maybe. Well, I'm going to do it right and make sure it's that. Yeah. All right. All right. So that's how we basically create new connections. And then every time we create a new connection, we should have, I don't know if we say here. You know what we didn't do though? We needed to add it to the new set. FD set. So we're going to add that connected socket we just created and add it to that master set we had. All right, so now that we got all of this kind of done, let's do our else statement right here, saying that if someone isn't trying to connect, if they were trying to connect, it'd be file descriptor 3, then it must be someone that's already connected, and they could possibly be sending a message. So I'm going to make a buffer to receive that message that they might be sending. And then do bytes received. And remember, this is a file descriptor. Socket is, like everything else in Linux, a file, so you can read from it. And if it's less than 1, then they they didn't send anything. There's no message. And we take it out of the FD set, the master FD set. We close the file descriptor and then continue with the rest of the loop. But if that's not the case and there was data, we can read through that data. All right, so basically right here, what we're doing is we're looping through all of our sockets again. And we don't have to start at 1, we can start at 3. Because of the reasons I said before, you know, the terminal automatically takes 0 through 2 for file descriptors, or check which ones are set for in the master set. And if the socket is the server, right? Socket listen is the server. If the socket is the server, then we continue. Or if the socket is the one who's sending them, who's trying to send the message, then we continue to the loop. We don't want to receive the message that we're sending. That would be kind of dumb. And so in any of those cases, we continue. Otherwise, we send the message to everyone on the server. And the send call may be used only when the socket is connected. Transmit messages to another socket. So it just transmits the message to another socket. Kind of didn't really need to pull it up that much, but all right. Then we go to the end. Printf strings socket close. All right, so we just print that we're done. We're closing the socket, and then we close the listening socket, and that should be everything. Right here, you'll notice, right, I took out string cat because before it said str cat. I took that out and changed it with sprintf. I didn't show that, and I put p error instead of fprint error here. So I did change this function a little bit off screen, just to let you know. All right, then let's run this and see how it works. And I am going to cheat a little bit only because so I made this kind of beforehand, right? I made a preparation beforehand. I'm going to run the client even though we haven't made the client, just for my own test reasons to see if it actually works. So I don't know if we made that. We didn't make the make file yet, right? Pretend like you didn't see that. So we're going to touch make file, and then we're going to write to it. Let's do build. GCC server does. Actually, just call it server. And start at, it just says the name of the, we just use the name of the recipe. Start at is the name of the recipe. Then out. Name of the recipe. Just try to run this and see how it goes. Client, boom. We see a bind failed. So if you ever see a bind failed, one of the things you can do, first you might want to use nmap to localhost if you're running this on your local host, and see if this port, the port you're running it on, isn't taken up, which obviously in my case it doesn't look like it is. But I can do fuser. I'm running it on port 8080. -K for kill. Anything on running an port 8080. It's a TCP socket. And it looked like it didn't work. Probably, I think you have to run it as sudo. Maybe not, but let's try it again. So, oh, I ran server and not client. That could be a good reason why it didn't work. But anyways, if for whatever reason you can't run the server program, maybe there's something else running and you can use fuser to kill it, but make sure it's not something important that's running in your computer. All right, so I got 2 people connected. Hello, should say hello to the other person connected. Nice. All right, yep, so we're sending messages back and forth. It works pretty well. And yeah, that concludes this video. Hope you guys enjoyed and learned a lot about network programming. See you next time.